so a couple of things I want to make you aware of is, number one, I did post a test schedule on Blackboard. You can print that schedule out, and I will stick to it unless something unforeseen happens. But as far as I can tell, this will be your test schedule. So again, if you want to print it out, keep it in your notebook, that would be great. So your next test, which will be Chapter 2, will be on the 3rd, which is 1 week from today. So 1 week from today, you will have a test on Chapter 2. And this is where we left off last week. So we got into fractions. And remember, I told you when you are solving an equation that has a fraction in it, the first thing you want to do is get rid of the fraction. And the way you're going to get rid of the fraction is you're going to multiply through by the least common denominator. So that, the one on the left, the common denominator between 2, 4, and 10 is going to be 20. So we started out by multiplying every single term. And remember, I told you you needed to know how many terms there were. There's 3 terms in here. So we multiplied all 3 terms by 20. Well, basically what you're doing without your calculator is you're saying 2 will go into 20 10 times, and then you're going to multiply 10 times that numerator. Drop your minus sign down. 4 will go into 25 times and 5 times the numerator. Bring down your equal sign. 10 will go into 20 2 times, and then 2 times 3 is going to be 6. And then from there you should be able to solve that equation. Now, if we have an equation like this, you're still going to do the same thing. You're still going to multiply through by the LCD. So the least common denominator between 3, 2, and 1, because there are 3 terms here. There's 1, 2, 3 terms. So the least common denominator between 3, 2, and 1 is going to be 6. So what I'm going to do is I'm going to multiply 3 by 6. So this you can do in your calculators if you want to. 6 times 2/3, or you can just say 3 will go into 6 2 times, and 2 times 2 is 4. So now what you're going to do is you're going to multiply 4 times that binomial. Bring down your minus sign. Again, half of 6 is going to be 3 times that binomial. And then don't forget 6 times 2, which is going to be 12. And from here, again, you can solve this equation. So take a couple of minutes, solve this equation, see what you come up with for t. Alright, so coming up with -2, we distribute the 4, and we're going to get 8t minus 4, and then we're going to distribute a -3, which is going to give us -9t, and then a +6, and then of course just bring down the 12. Now on the left hand side, we're going to combine like terms. 8t and -9t is going to be -1t, and 4 and 6 is going to be 10. We're going to take the 10 over, so if we minus 10 from both sides, we're going to get 2. And so you have -t is equal to 2. So t is going to be equal to -2. Just divide that through by -1. Alright, let's see if you can do the one on the bottom. If you want to get in your groups, you can. So let's see how we did. What did you use for the LCM? 18. Good job. Alright, so 2 will go into 18 9 times. And so we'll have 9 times a minus 3. Minus 9 will go into 18 2 times. So we'll have a plus 4. And then 6 will go into 18 3 times, and 3 times 7 is going to be 21. Now we're going to distribute, so we'll have 9a minus 27 minus 2a minus 8 equals 21. So we'll have 7a minus, 35 equals 21. So if we add 35 to both sides, we're going to have 7a is equal to 21, and 35 is going to be what, 66? No, 56. And then if we divide both sides by 7, You came up with A is equal to what? Very good. So how'd we do? Everybody do okay? Any questions? What's wrong? Anything? Everybody good? Okay. Again, the number one thing that I want to caution you about is those minus signs look at you every single time. When you go through and you start distributing, make sure you distribute that negative sign all the way through. It will catch you. This stinking little number right here will catch you every single time. Okay? So make sure when you take that negative, or that -2 through, make sure you carry it all the way through. Make sure you remember your integer rules. Okay, let's go back to some word problems, because I know y'all just love these. Find a number such that 3/8 of the number minus 1/2 of it is 14 less than 3/4 of that same number. Now, we're talking about the same number, so just choose a variable to represent the number all the way through, okay? So we're going to have, for example, 3/8, and we'll just say n. You can use whatever variable you want to. 3/8 of a number minus 1/2 of the number. Now, remember, subtraction is kind of tricky, because if it says less than, you're going to write it backwards of what you see. But if minus just means you're going to take it away, so you can write it straight up. Is equal to 14 less than, for example. 14 less than 3/4 n, you're going to write 3/4 n minus 14. So with subtraction, make sure you be careful on how you read it. Make sure you understand what you're reading. Alright, see if you can solve this one. So, again, we're going to multiply through by 8, but like I said, if you chose 16, 24, any multiple of 8 would have worked. So, for the first one, did you come up with 3n? Minus 4n? And then 6n? And then whatever 8 times 14 is? Thank you. Alright, so we got some things we got to get together now. So 3n minus 4n is going to be a negative n. As long as you're on the same side, remember you're just combining like terms. I hope I've gotten that through your head by now. But when I bring the 6n over, I have to do the opposite. As long as you're staying on the same side, you leave the signs alone. So that's going to be a negative 7n is equal to negative 112. And then if you divide through by negative 7, you come up with n is equal to what? Good job. Alright, so word problem like this is not that bad. Honestly, it's not half as bad as the one we did the other day. The other day was a booger, so this one's not near as bad. Alright, so let's look at this one. It says the width of a rectangular parking lot is 8 feet less than 3/5 of the length. The perimeter of the lot is 400 feet. Find the length and the width of the lot. So we're talking about a rectangle here. And we know the word perimeter has a formula to go with it. How do you find the perimeter of a rectangle?
Add all sides together.
Yes, but what's the formula? 2 times the length times 2 times the width. There's your formula. Okay, so let's go back and read how to set this up. It's telling us that the perimeter is 400 feet, so we're not looking for the perimeter. And it says the width of a rectangular parking lot is 8 feet less than 3/5 of the length. So we don't know anything about the length, so the length is just going to be the length. The width, on the other hand, is going to be 3/5 of the length, and then less than that by 8. So you're going to have 3/5 L minus 8. And remember, I wrote it backwards because of the less than. If it had said minus or take away, I wouldn't have written it backwards. Alright, so let's substitute in. 2 times the length. We don't know anything about the length, so that's just going to be length. Plus 2 times the width. The width is 3/5 L minus 8. See if you can. What'd you do? Do what? One more time. What? Can you get a mixed number?
Like, not with the answer, but like, you know, problem with it.
Yeah, because when you distribute that 2, you should get a mixed number, right?
Yeah. Okay.
Or an improper fraction, whatever you want to do. Why are there 2 equal signs in this problem? Okay, at this point, did you get rid of the fraction or did you just go with it? Did you leave it or get rid of it? I'm hearing mixed reviews. You left it? We can do that. Okay, so we'll add 16 to both sides. So we'll have 416 is equal to, what's that going to be? Oh, this calculator's not working. That's not good. Well, yeah, but I'm just trying to get my calculator to work. It's not working. I don't know why. Alright, so anyway, 3 1/5 or what, 16/5? Either way, that will work. Now, how do you get rid of a fractional coefficient? Multiply by the reciprocal. So we're going to do 5 over 16 on both sides. Alright. So our length is going to be equal to what? Will that go evenly if I had a calculator that worked? $130. So what you got for the length? 130? No? Well, we're going to multiply by 5/16, right? 5/16 times 4/16, yes? 130? Yes? Yes? Okay, so there's the length. Now let's find the width. The width is going to be 3/5 times the length minus 8. So let's do 3/5 times 130. It's going to be 78 minus 8 is going to be 70. So the width is 70 and the length is 130.
How did the 16 feel?
Yeah, 2 plus 6/5. Combining those like terms. Alright, so on your test 1 week from today, expect a rectangle problem, because we will have one of those on there, for sure. Alright, let's talk about decimals. As far as decimals are concerned, since you have a calculator, it should not be that big of a deal. However, if you want to get rid of the decimals, you can, by the same way we got rid of the fractions. For example, the one on the left, the biggest place value is the hundredths place. So you can multiply that whole entire equation by 100 and all your decimals will be gone. If you multiply through by 100, for example, if you multiply 0.2 times 100 in your calculator, you should get 20x. If you multiply 0.24 times 100, you'll get 24. If you multiply 0.8 times 100, you'll get 80. And then 0.72 times 100, you'll get 72. And all the decimals will be gone. And that's fine if that's what you want to do. Just find the last place value, which is the hundredths place, and multiply through by 100. The one on the right, the last place again is the hundred, so you do the exact same thing. But to me, since they're decimals, you have a calculator, it's easier just to do your rules that we learned about at the beginning of the equations. So, for example, I know I need to get the x's on one side and the non-x's on the other side, so I'm going to minus 0.8x from both sides. And if you went the other way, that's fine. So here we're going to get what? All right, and then we'll get the 0.24 over here. So we'll have negative 0.6x is equal to positive 48. And then if we divide both sides by negative 0.6, you're going to get x is equal to what? To what? So again, like I said, if you have the calculators, just use the calculators. Or if you want to get rid of this calculator's not gonna matter. Do the one on the right. See what happens. Y'all don't know how to use a calculator. So that's going to be 80. This is negative 80. I didn't think that was right. 48.
It should be 0.
It's 0.48. That's what it is. Okay, my bad, my bad, my bad. Okay, so I left my decimal out. Alright, so the one on the right, you have 0.04 plus 0.08, which is going to give you 0.12 m. Remember, you're on the same side, so you're just putting them together. Is equal to 4.8. Divide both sides by 0.12. And you're going to get m is equal to what? You're going to get 40. Should get 40. Are we okay? Are you good? Okay. All right, so let's do this word problem. This one talks about money. So Erin has 28 coins consisting only of dimes and quarters worth $4.60. How many dimes and how many quarters does she have? Well, how much is a dime worth out of a whole? 0.10. So we know that we have 0.10 dimes. X. 0.10x represents how many dimes we're going to have. And then plus 0.25, right? That's a quarter. But however many dimes we have, we're going to have to take that away from the total in order to get the quarters, right? So the quarters are actually going to be 28 minus x. And do you understand where that came from? You're going to have 28 total coins minus however many dimes you have, and that's the x. Because we did 0.10 times x. 0.10x, 0.10 dimes, however many dimes. So to get our quarters, we got to do 28 minus however many dimes we're going to get. So it's going to be 28 minus our total number of coins minus our dimes. Is that better, Chloe? Good deal. All right, it's equal to $4.60. Take this equation and solve it, please. Remember, all right. So going through here, again, you're doing the distributive property. So 0.25 times 28 is 7. 0.25 times negative x is negative 0.25x. Then what I did is I combined the 0.10 and the negative 0.25 and got negative 0.15 plus 7. Yes. From here, you're going to minus 7 from both sides. So if I minus 7 from 4.6, because I need to get the 7 over here, you're going to get negative 2.4. To get the x by itself, I'm going to divide both sides by negative 0.15, so x is equal to 16. What does that mean? There are 16 dimes. So if I have 16 dimes, how many quarters? How many quarters? Thank you, Chloe. Okay, so we got 16 dimes and 12 quarters. Do you understand how to do a money problem? Take your smallest currency and put it with the x, okay? So example 10, and that's a big hint because on the test I may have nickels and dimes, or I may have nickels and quarters. Take your smallest currency and put it with your x, okay? So if it said nickels and quarters, you do 0.05x. And then make sure you multiply your biggest currency times your total number of coins minus your x, of course. From there, you should be able to. Once you get the equation set up, you should be good to go. Okay. Just make sure you get the equation set up correctly. One big mistake is people get this backwards. Remember, it's total minus your smaller currency. Total minus your smaller currency. All right, so let's talk about formulas. You can do this. Same concept, it's just real world formulas that we're using now. So for example, we're still talking about money here. Talk about interest. Simple interest, I equals PRT. I is your interest, P is your principal, R is your rate, and T is your time. R rate, that's going to be a percent. I'd rather you change it to a decimal. You know how to change a percent to a decimal. If I tell you something is 8% as a decimal, you're going to move it 2 places, not 3, 2 places to the left. Move your decimal 2 places to the left and you get 0.08. Okay? Anytime you want to change a percent to a decimal, you're just going to move the decimal 2 places to the left. And then your time, T, that's going to always be in years. If not, you need to fix that. So, look at the directions for this problem. And it's kind of tricky to read it, and that's why I put it on here because this is how you're going to see it on the test. It says solve this formula for I. So in other words, you're going to take the interest formula and you're going to figure out how much interest is going to be accumulated. Okay? So I is equal to your principal, which is 300, times your rate, which is 0.08 or 8%, times your time, which is 5 years. From here, it's pure calculator work. Just multiply it all straight in. 300 times 0.08 times 5, and you're going to get $120. Understand you are talking about money, so make sure you represent it as money. If I ask you for the rate, you're going to give me an answer as a percent. Okay? And then, of course, if I asked you for time, you're going to give me the time in years. So make sure you give me the answer that I'm looking for. Okay? Try this one. Alright, so again, I will give you the formula. So your formula is I is equal to PRT. Principal is your amount that you're going to invest. So if we're going to invest $3,500, and then we're going to multiply that times our rate. And remember, 2%, your decimal's here. You got to move it 2 places. So that's going to be 0.02. And then time in years is 15, so we're good. Alright, so again, straight calculator, type it in, 3,500. Most people, I think everybody in fact, got this. Okay? Easy enough? Just be careful when you're changing your percent to your decimal. Make sure you get that right. Alright, accumulation. Accumulation is how much total you're going to bring home. Okay? So you have to understand the difference in your formulas. Look at this. Here is your interest that we just came through, right? Well, if you go to the bank and you invest something, are you only just going to bring home the interest and leave the amount that you initially took there? No. That'd be a total ripoff. So accumulation is actually what you're going to bring home. You're going to bring home the principal that you initially invested plus your interest. Okay? So let's find this out. Solve your accumulation, but look, it says solve the accumulation formula for R. So we're looking for rate this time. Okay? Watch this. A is given to us. So A is 516. Our principal is 300. But you have 300 plus 300 times the rate, which is what we're looking for, times 8 years. Now my question to you is this. I know that you can solve this equation. But I'm going to let you, as your group, figure out your first step. And you can go one of two ways. Once you get your first step decided on, then go with your second step, and then I'll catch up with you. Go, you got 1 minute to discuss this. So, the number one thing, and this is why I wanted you to talk about this as a group, because on the test, if I give this problem, about 50% of the people would add the 300 and the 300 and get 600, and ironically, sometimes they get 900, and then do the R times the 8. You can't do that. You cannot do that. So, what you're going to do is you're going to do 516 is equal to 300 plus 2400 R. Now it's an equation that you can solve. But you cannot add the 300 plus the 300 R8. Those are not like terms. One has an R, the other one doesn't. So make sure you learn that lesson now and don't do it a week from today on the test, please. Now you know what you're going to do. You're going to minus 300 from both sides. And so you're going to have what? 216 is equal to 2400 R. And then if you divide by 2400, you're going to get 0.09. Now let's see how many of you were listening about 5 minutes ago. What would you put on your answer blank? Excellent. Excellent. When I ask for a rate, I am asking for a percent, so I need 9% as your answer. Okay? Now if you put 0.09 on the answer blank, I'm probably going to give you half credit, but please give me what I asked for. I want a percent. Okay, what if we have an equation, a formula, but we don't have any numbers to plug in, but you still need to solve for something? This is called a literal equation, and what you're going to do is you're going to use the exact same moves that you would in solving an equation, except you're just not going to have any numbers to deal with, which means your answer is not going to be a nice, neat little answer. Your answer is going to be something kind of crazy. And so you have to be careful how you write your answer, because only one thing will work. Only one answer will work. All right. So what I have here is the formula for the area of a triangle. Y'all recognize that? 1/2 base on top. I want to know H. I want to know H. Let's say that you're an architectural engineer and you have a city block, and this guy wants you to build a triangular building for him. Well, there's a height regulation, possibly. I don't know. So you need to know how high you can build this thing. And that depends on how big the base can be. And that depends on your city block and other regulations. So if we take this and we have a certain area that we have, area is equal to 1/2 base times height. And I need to get h by itself. That's straight multiplication. First thing you want to do is get rid of what? That stinking fraction. How do you get rid of the 1/2? You're going to multiply by 2 over 1. Well, on the left-hand side, 2 times a is 2a. Now, on the right-hand side, this is where it gets tricky. That is one straight product. That you may as well be looking at 2xy. If I multiply 2xy times 2, what do I get? We don't multiply the 2 times the 2 times the x times the y. We don't get 4, 2x, 2y. I don't even understand that. But anyway, on the right-hand side, when you multiply 1/2 times that 2, what happens? It cancels out. That's the whole point. That's the whole point. So on the right-hand side, you're going to be left with b times h. Now I need h by itself, which means I need to get rid of b. That says b times h. What's the opposite of multiplication? So we're going to divide both sides by what? What we need to get rid of. So we have 2a over b is equal to h. Now in a simple problem like that right there, you would be amazed at what kind of answers I get. If you tell me the answer is 1/2 a over b, I'm going to count it wrong. Because you told me technically it was a over 2b. And that's not right. Okay? So you have to be careful on how you write these answers. Be very, very careful. I'm going to do the one on top with you. The one on the bottom you should be able to do. The one on the top. We need to get to this b2. b sub 2. This is the area of a trapezoid, by the way. But that b sub 2 is embedded in grouping symbols. So somehow or another we need to get rid of those grouping symbols. Why are the grouping symbols there? True. But why are the grouping symbols there? Distributive property. We have distributive property. Well, we certainly don't want to distribute. That's going to complicate matters. But instead, what we want to do first is we want to get rid of what we would normally distribute by. Which means we want to get rid of what first? What's the first thing you always want to get rid of? The fraction. First thing we're going to get rid of is the fraction. So we're going to multiply again by what? The reciprocal, which is 2 over 1, or just 2. So on the left-hand side, again, we're going to get 2a. On the right-hand side, watch, because this is a huge mistake a lot of people make. A lot of people will say 2 times b sub 2, and 2 times b sub 1, and then 2 times the 1/2 h. And you're getting, somehow or another, you're left with 2h times 2b1 plus 2b2. The whole point in multiplying this 2 is to get rid of this 1/2. And that's what happens. That's exactly what happens. And so what you're left with is h times b sub 1 plus b sub 2. Well, our parentheses didn't go away just yet. We have one more move. What would it be? Divide by h. That says h times the group. So we're going to divide by h. Now our parentheses can go away. So now we have 2a over h is equal to b1 plus b2. Now do you remember what we were looking for? We need to get b sub 2 by itself. So that means we need to get rid of what? B sub 1. That's a positive b sub 1, right? So how are we going to get rid of it? We're going to minus b sub 1. Now this is where people want to go just nuts with this answer. On the right hand side we're left with b sub 2. That's good. See if you can write the answer. See if you can write down the answer. It's just the base. Alright, if you're still working on this this answer, you're being way over thoughtful. Way over thoughtful. Because the answer is this. You have two terms on the left-hand side. You have this term and you have this term. And they're subtracted from each other. So your answer is going to be 2a over h minus b sub 1. And that's all you got to write. That's all you've got to write. Now, what do people do? They do 2a minus b sub 1 on top, all over h. That's not right. That is not right, because you have to have a common denominator then. And technically, it would be 2a minus b sub 1h all over h. So you can't do that. Then some people will say, well, why not just do 2a over h minus b? Well, how did minus b get in the denominator? Okay? So you have to understand that you have two terms that you're subtracting. And you just write it like that. You just write it as two terms minus from each other. Okay. The one on the bottom, y'all have done this 20 million times. I know my 09-8ers did it. We did it when we studied the linear section, chapter 3, solving equations or graphing linear equations. Can anybody tell me what form this equation is? 2x minus 3y is equal to negative 1? Starts with an S. Standard form. Very good, KJ. This is standard form. And I'm asking you to take this standard form equation, linear equation. You're going to have to do this in chapter 7 a whole bunch, so you may as well learn how to do it now. And I'm asking you to solve it for y. What does that mean? What form is your answer going to be in? Y equals mx plus b. It's going to be in slope-intercept form. So that's what I want you to do. I want you to take this equation, and I want you to solve it for y. All right. Will you at least tell me what your first step was? Let's minus 2x from both sides, because you already got a positive 2x, but that's right. So let's minus 2x. So we'll have a negative 3y is equal to, now remember your goal, y equals mx plus b. So you want your x term to come first. So we'll have a negative 2x, and then your b to come next, so you have a negative 1. You cannot put negative 1 and negative 2x together. They're not like terms. One has an x, the other one doesn't. This is stuff that y'all heard me say 20 million times. All right, Marcus, what's the next step? If I wanted to get y by itself, that says negative 3 times y, what am I going to do? Yes. And when you divide by negative 3, watch this. There's 3 terms. So you're going to divide all 3 terms by negative 3. Okay? So this goes to 1. That's good. So we have y is equal to, watch, negative divided by negative is a positive. And you're going to have 2/3 x. Again, negative divided by negative is positive, plus 1/3. So you have y equals 2/3 x plus 1/3. Okay, for chapter 7 purposes, can you tell me what the y-intercept is? 1/3. And can you tell me what the slope is? Excellent, excellent, excellent. Good job. All right, take this one and solve for D. All right, so let's remember, let's remember this problem, please, for testing purposes, okay? This is a great problem to see if you really understand what's going on in an equation. I'm trying to get D by itself. If I don't have a fraction, the first thing I need to do is addition and subtraction. So I need to get rid of this S. So that's a positive S, so we'll minus S from both sides. So we'll have P minus S is equal to negative S dt. That's straight multiplication. Negative S dt is straight multiplication. To get to the D, I'm going to have to divide by what I need to get rid of, which is the negative S and the T on both sides. So we'll have P minus S over negative S T is equal to D, because that canceled out, and the negatives went away. So make sure you remember this one. Make sure you remember your the one that we did with the triangle formula as well. Something like that, you'll see. Alright, here is another rectangle problem. Let's see if you can suppose that the length of a certain rectangle is 2 meters less than 4 times its width. So we don't know anything about the width this time. But we know that the length is 2 meters less than 4 times the width. And we also know that the perimeter is 56 meters. So remember the formula, P is equal to 2L plus 2W. So your perimeter is 56 is equal to 2 times the length, which happens to be 4W minus 2, plus 2 times the width, which we don't know anything about. And then it says find the length and the width. Alright, so we have 56 is equal to, hopefully you got it set up that way. How many of you got it set up correctly? Yay. Okay, take the 2, multiply through, so we're going to have 8W minus 4 plus 2W. 56 is equal to, on the right hand side, we're going to combine like terms. We're staying on the same side, so we're just going to put that 8W and that 2W together, so we'll have 10W minus 4. Then if we add 4 to both sides, we'll have 60 is equal to 10W. Divide both sides by 10, and we're going to get our width is equal to 6. How'd we do? So if our width is 6, what is our length? Our length is going to be 4W minus 2. So we're going to have 4 times 6 minus 2. So we'll have 24 minus 2, which is 22. How's that? So that one wasn't so bad, right? Alright, let's talk about a little bit about inequalities. This just will help you reinforce your equation solving techniques. Everybody in here knows how to solve an equation. I'm very impressed with what y'all are doing. So let's just go ahead and talk about this. Alright. You have your inequality symbols. You have less than, and you have less than or equal to. What's the difference between these two? The line underneath. What does that mean? So in this one, if I said 3 is less than 3, true or false? False. False. If I said in this one 3 is less than or equal to 3, true or false? Do you understand the difference? Okay. So here we have greater than and greater than or equal to. Now look at this statement right here. The one in black. To solve an inequality, we would use the same process as solving an equation with one exception. So you all know how to do this. You already know how to do this. So what is that one exception? You know when you're solving an equation in the very last step is to try to get that coefficient to be 1. The very last step, you divide. Okay. If you ever have to, in that last step, it doesn't occur until the last step. If you ever have to multiply or divide by, and this is the key word, a negative number, then you got to turn that inequality around. Okay? And that's the only difference. So you don't even have to worry about it until that very last step, and then you need to think, if I'm multiplying or dividing by a negative number, I got to turn that inequality around. If not, just leave it be and move on. Why? Well, watch this. When you're talking about an inequality, you're going to talk about number lines. Because now when you solve an equation, you're going to get something like x is less than 3. How many numbers are less than 3? Right here is 3. How many numbers are less than 3? All the way to negative infinity. So when you're talking about inequalities, you have to think about a number line because we're talking about an infinite amount of numbers. So watch this. Let's take a basic inequality. 2 is less than 5. True or false? True. And let's multiply by a positive number. So now we get 8 is less than 20. True or false? True. True. So it doesn't mess with the number line at all. Let's go here. 2 is less than 5. We've already said this is true. Let's multiply by a negative number. Negative 4. When you multiply by a negative number or divide by a negative number, it takes you on the other side of the 0. It takes you on the other side of the number line. And the rules are different over there, aren't they? Because look now, negative 8 is less than negative 20. Well, if it's less than, it's going to be to the left of it, right? Negative 8 is up here and negative 20 is back here. Which one's closer to the right?
-8.
-8. And that's why you gotta turn that inequality around. Okay? So that negative is gonna throw you on the other side of the number line, which means you got to turn that inequality around. Alright. In this class, what we're gonna do is we're going to do our solution 2 ways. Okay? Obviously you're gonna solve it, but to write your solution, and this is new to Math 100. Okay? 098, you didn't see this. High school, it's questionable whether you saw this or not. But from this math class on, you're going to have to know how to do this. Okay? So if this is your last math class, learn it for the test and then forget about it. If you got to go to 112, definitely learn how to do this. Once you get your solution, the only reason I show you set notation is because you'll see it in the book. All this means is when you solve an equation and you get something like x is greater than 2, it's going to be x such that x is greater than 2. No big deal. Set notation, I'm not going to ask you to write your answer in set notation. I'm just showing you this so you'll see it in the back of the book. You'll know what you're talking about. We are going to graph them. I do want you to be able to graph them. I want you to be able to, if I say x is greater than 2, could you put that on the number line? You're going to color all numbers greater than 2. Okay. Now, this is new. This is something we didn't do in 098. You remember open circle versus closed circle? Okay. Open circle are now going to be your parentheses. When you see a parentheses, that means it cannot be equal to. That's the same as your open circle. Closed circle are your brackets. When you see a bracket, that means can be equal to. Okay? This is called interval notation. So on the test, if I say give your answer in interval notation, make sure you write with using your parentheses or brackets. And I'm going to show you how to do that. Okay. If you have these symbols, do you see these? If you see these symbols, your answer better have some brackets in it. Okay? If you see less than or equal to or greater than or equal to, your answer should have brackets in it. If your answer has infinities, either the negative infinity or the positive infinity, infinities will always carry a parenthesis. You can never equal infinity. You die before you get there. Okay? So just remember that. 2 things. If you see less than or equal to, or greater than or equal to, you're going to use a bracket. Anytime you see an infinity, you're going to use a parenthesis. So make sure you understand that. Okay. Notice the directions say solve and graph. And then on the test, it's going to say write your answer in interval notation. So on the left-hand side, problem number 1 on the left-hand side, you know how to solve this. Treat it like an equation and get x by itself. Go. And you should come up with x is greater than -3. Alright, so we're going to minus 5 from both sides, just like before. And so we'll have 2x greater than -6. Divide both sides by 2. And so you're going to have x is greater than -3. Some of you may be saying, now wait a minute, you said if we're dividing by negative, we're going to turn that inequality around. We have a negative there. Why did we not turn the inequality around? Watch this. Remember I boxed in the word by? You have a -6 here. Are we dividing by -6? No. You're not dividing by -6. You're dividing by a +2. That's why the inequality didn't come around. It's only if you divide by or multiply by a negative number. Doesn't matter what you already got. Okay? So, here's our solution. X is greater than -3. Now, I want you to graph it. On the test, I will already have the number line there for you, so you don't have to worry about drawing all the number lines. It's always already going to be there. For your study guide, if you're going to turn that in, the only thing I require is the number that's in question, which in our case is -3. Is this going to be a parenthesis or a bracket? It's going to be a parenthesis because it's not equal to. And then is it going to be, are we going to color? Because remember, you're going to color the numbers that it can be, x can be. So give me an example of some numbers that x can be. -2, -1, 0, all the way to positive infinity, right? That's what those arrows mean. So this is what you're going to do. You're going to put a parenthesis at the number in question, not a bracket, because if I see a bracket, you're telling me that it can be equal to, and it cannot. So you're going to put a parenthesis at -3, and then you're going to color all the way to the right. X is greater than -3. So there's your graph. Now, interval notation. If you get it graphed correctly, your interval notation should be fairly easy. Okay, because all you're going to do is copy the graph, basically. Watch this. You're going to have a parenthesis from -3. Your comma is going to include all your coloring. To positive infinity. What always goes with the infinities? Parentheses. Because you can never equal infinity. You'll never get there. So you're going to have from -3 all the way to infinity. So, this is what I should see in your work. This is what I should see on your graph. And this is what I should see on the answer line. Okay? I will see you, Lord willing, Wednesday. Put your desks back where they go, please.